Hello my dear friends, how are you all? I hope you all are fine. So you are very welcome in a lecture number 3 of exponents and powers. Okay, so my dear friend, this lecture is going to be very amazing, so you have to be listen very carefully. So let's start without wasting the time. Yes, so today here we are going to discuss use of exponents to express small numbers in standard forms. Okay, understand my dear friends? So now basically what is the standard form? Okay, so a number is said to be in standard form if it is expressed as the product of a number between 1 and 10. If we expressed the product of a number between 1 and 10 and the integral power of 10. Okay, now if you see the example, let's suppose we have a number like this: 149,600, okay, 00,000. Okay, so how many zeros? 1 2 3 4 5 6 7 8. Understand? Now here we have to express this number in this standard form. So how we can express it? So here we are writing that the standard form is what? It is that form in which if we expressed this number in the between 1 and 10 and integral power of 10, so we can write it as, here we can write 1.496. Here we are putting the points, decimal points, and we can write into 10 raised to power. Here we have 1 2 3 4 5 6 7 8, so 8 zeros plus, and we are putting the decimal in which digits. So 1 2 3, so it means before 3 digits. Okay, so it means this will become like after the decimal points. How many total digits? 1 2 3 4 5 6 7 8 9 10 11. So it means we can write 10 raised to power 11. 10 raised to power 11. Got it? So this is what? This is the standard form. Okay, now very small numbers can be expressed in standard form. Can be expressed in standard form using negative exponents. Using what? Negative exponent. Now for example, here suppose we have 0.0016. Okay, so now we have to express this into the what? Into standard form. So for converting this, first of all, if we remove this point, here we get 16 upon, after the decimal, how many digits? 4, so we can write 10000. Okay, it means 40 will become. Okay, understand? Now here if we convert this into standard form, this will become like this 10 will goes to the numerator and it will become like 1.6, and we have left 3 zeros. So and if we shift these 3 zeros to the numerator, this will become 10 raised to power minus 3. Okay, in denominator it is what? 10 raised to power 3, and after shifting to the numerator, then the power will become negative. Okay, so this will become, yes, 10 raised to power minus 3. So very small number, this is very small number, can be expressed in the form of, in the standard form using negative exponents. So this is what? Negative exponents. I hope you understand these things, my dear friends. Yes. Okay, so we know that very large number or very small numbers can be represented in the standard form with the help of exponents. With the help of exponent. Now let's see the method to convert into the standard form. So here is, if it is a very large number, or we can say very large number like 150 000 Now we have to convert this into what? Into standard form. Then here, then we need to move the decimal place towards the left. Here it is saying that we need to move the decimal point, here decimal place towards the left, means towards this side. Then, and when we do so, the exponents will be positive. Then the exponents will be what? positive. Okay, like here you can see that 1 5 0 0 0 0 0 0 0 0 0 0. Okay, okay, now if we count the digits after the first number of this number. Okay, so here you can see that after 1 how many digits are there. So if you count this, we can get 1 2 3 4 5 6 7 8 9 10 11. So how many digits total there are 11 digits. Since the decimal is moved 11 places till it is placed between 1 and 5. Okay, so here our standard form representation of the large number here will be 1.5. Okay, understand, into 10 raised to power 11. What is 10 raised to power 11? So this is the standard form. I hope you understand these things, that how to convert large number into the standard form. Okay, we will do a lot of problems based on this. Okay, so no need to be worried. Yes, now if a number is very small, okay, like this 0.000007, then how we can convert it into the standard form. So now we need to move the decimal places to the right. To the what? To the right means to the right direction, in order to represent the number in its standard form. Now when being shifted to the right, the exponent will be negative. The exponent what? The exponent will be negative. So here we have 0.000, okay, 007. We have this number. Okay, here and here we need to move this decimal point. We need to move this decimal to the right direction. To the what? To the right direction. So in this case the decimal place is moved. Here is how many digits are there. So 1 2 3 4 5 6. So there are total 6 digits after the decimal. So here the decimal place is moved 6 places. Okay, 6 places until it is placed after digit 7. Okay, so therefore our standard form representation, like here you can see that 7 into 10 raised to power minus 6. 7 into 10 raised to power minus 6. Okay, understand. So this is our definition of the standard form, that a number is said to be in the standard form if it is expressed as a product of a number between 1 and 10. Here you can see that here we have a number between 1 and 10 and the integral power of 10. Here you can see that this is the integral power of 10. So this is what? This is the standard form. This is the standard form. Yes. Now we are going to solve the problems. Okay. So here is express the following numbers in standard form. Okay. In what? In standard form. So here you can observe this. This is what? This is very small number. So here we have to move this decimal point to the right. Okay, in this direction. So here we have 0 point. Okay, here how many zeros are there? 1 2 3 4 5 6 7 8 9 10 11. Okay, so 1 2 3 4 5 6 7 8 9 10 11, and here we have what is 1 2 3 4 5 6 7 8 9 10 11, and here we have 8 5. Okay, so here we have to move this decimal, okay, up to until this decimal point is placed between 8 and 5. We cannot place this decimal point to after the 5, because if we place this point then it will become like 85. So we have to place the number between 1 and 10. So we have to place this point up to when this point is placed between 8 and 5. Okay, so 8.5 into 10 raised to power. So between this point and 8, how many digits are there? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how many digits are there? 12. So we can write it as into 8.5 into 10 raised to power minus 12. If we convert very small number to the standard form, then the exponent, or we can say then the power is what? Then the power will be in negative. Okay, understand my dear friends? So this is what? This is the answer of this problem. Okay, so this is the method to convert very small number to the standard form. Now here we have to convert this. So here is, now we have to place this decimal point after the 9. Okay, after the 9 we cannot place like after the 4 or after the 2, because this will become greater than 10. So after the 9 if we place this, so between this decimal point, if we are putting this and this decimal point, how many digits are there? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many digits are there? 12. So we can write 9.42, okay, into 10 raised to power minus 12. We can write what? 10 raised to power minus 12. Okay, so this is the answer. Again, this is very easy. Okay, yes. Now here is, this is what? This is very large number and we have to convert it into the standard form. Into what? Standard form. Okay, so here we are placing the decimal after the 6 and before this 0. Okay, yes. So 6 point, here is 6 point. So we can write here, you can see that after these 6, how many digits are there? How many digits are there? So if you count this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. How many digits are there? 15. So 6.02 we can write into 10 raised to power 15. What is? Yes, we can write it as 10 raised to power 15. So I hope you understand these things. So this is what? This is in standard form. This is the standard form of this number. Got it? Yes. Now the next is, now again here we have to convert this number into the standard form. So this is what? This is very small number. So here we have to shift this decimal to the right and we have to place this decimal before, okay, before 8, before 3. Okay, before what? Before 3. Okay, so between, how many digits are there between this point and 3 is 1, 2, 3, 4, 5, 6, 7, 8, 9. So here we can put the decimal after 8.37 into 10 raised to power what? 10 raised to power minus 9. Okay, what is 9 minus 9? Because we are converting very small number to the standard form. Understand? Yes. Now the next you can see that again, this is what? This is very large number. This is what? Yeah, this is very large number. So now how we can convert it into the standard form? So we can convert it into the standard form like, here we have 3. Okay, we can put 3 point. Okay, and after the 3, how many digits are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can write 3.186 into 10 raised to power 10. Okay, so the exponent is what? Is positive in this case, because we are converting very large number into the standard form. This is what? This is the answer. So my dear friends, I hope you understand these things. Yes. Now express the following numbers in usual form. Now here we have to convert standard form from we have to convert the standard form into usual form. Okay, and in the previous question what we are doing? We are converting the usual form into the standard form, and here we are converting the standard form into usual form. So how we can convert it? So let's see that. here we have 3.02 into 10 raised to power minus 6. 10 raised to power minus 6. Okay, so we can write it as 3.02 upon, if we make the negative power become positive, then this will become like 10 raised to power 6. Okay, so we have in the denominator is 10 raised to power 6. Understand? So if we shift this, if we place these zeros to the number, here we get 0.000000302, because you can see that we are shifting 6 digits. Okay, we are shifting this point to the shift 6 digit in the left, in the what, in the left. So after before this decimal, here 6 digit is what, this 300000. So if you count this, so there are 5 digits, 1 2 3 4 5 6. Okay, so and in the denominator is what, we have 6, 10 raised to power 6. So this is what, this is the usual form. This is the usual form. Understand? Yes. Now the next one, here you can see that next, here we have 4.5 into 10 raised to power 4. So this is very easy. Remove this point. Here we get 10 in the denominator. So this 1 0 cancel this one out of this 4 0. So here we get 45 into 10 raised to power 3. So we can write it as 45. How many zeros? 3 zeros. So put the 3 zeros. So 0 0 0. This is the answer. 0 0 0. This is what? This is the answer. Yes. Now the next problem is, here we have 3 into 10 raised to power minus 8. So we can write 3 upon 10 raised to power 8. So here we have to yes, we have to leave the 8 digits. So we can write 0.000000003. Okay. So after the point, how many digits are there? 8. 1 2 3 4 5 6 7 8. So this is the correct answer. This is what? This is the correct answer. Okay, yes. Now here we have to convert 1.001 into 10 raised to power 9 into what? Into 10 raised to power 9. So now if we remove this point, here we get 1 0 0 0 0, because after the point here we have 4 digits. So we can write 1 0 0 0 0 in denominator. So 4 0 will become. Okay, now in the numerator, here we have 9 zeros, because it is 10 raised to power 9. So here we can write this 4 zeros is cancel. Here we get 5 zeros. Okay, so here 1 0 0 0 1 into 10 raised to power 5. Okay, so now put these. Here we get 1 0 0 0 1 0 0 0 0 single 0. Okay, okay, so this is what, 5 digit, because we have 10 raised to power 5. This is the answer. This is what? This is the answer. Okay, my dear friend, I hope you understand these things. Yes, now the next one is, you can see that now here we have 5.8 into 10 raised to power 12. Okay, so we can write it as 5.8 into 10 raised to power 12. If we remove this point, we get 10. Okay, so this one zeros will be cancelled. Okay, so here we get 11. So 58 into 10 raised to power 11. It means we can write 58. Okay, and we can place the 11 zeros. Okay, 0 0 0 0 0 0 0 0 0 0 0. Okay, how many zeros is there? 11 zeros. You can count it like 1 2 3 4 5 6 7 8 9 10 11. Okay, this is the answer. Yes, now next one, here you can see that here is 3.61492 into 10 raised to power 6. What is 10 raised to power 6? Okay, so if we remove this point, here we get how many zeros are there? So here we have 1 0 0 0 0 0, 5 zeros, because after this point here we have 5 digits. Okay, understand? And here you can see that here is 6 zeros and here is 5 zeros, so this will be cancelled. So here we get just 1 zeros. We left is 1 0. So here the 6 361,492 into 10. So this will become 361,492. This is what? This is the answer. This is the answer of this problem. I hope you understand these things, my dear friend. Yes. Now the next one here you can see that express the number appearing in the following statement in standard form. Okay. Yes. So here it is saying that 1 micron is equals to 1 upon 1,000,000. Okay. So how many zeros are there? 1, 2, 3, 4, 5, 6. So it is saying that 1 micron is equals to 1 upon, here is what? 1 upon 10 raised to power 6. What is 10 raised to power 6? So if you convert it into the standard form, we can write it as like 1 into 10 raised to power minus 6. 1 into 10 raised to power minus 6. Okay. Got it? Yes. Now the next one is, now charge of an electron is, here you can see that charge of an electron is 0.00000000000000016 coulomb. Okay, so how many zeros are there? Here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. How many zeros are there? 18. And here we have to put the place between 1 and 6. Okay, so between this point, between this decimal and this 6, how many digits are there? How many digits are there? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 and 19. So we can write 1.6 into, we can write what? 1.6 into 10 raised to power minus 19 coulomb. Okay, that is coulomb. This is the unit. Understand? Got it? Yes. Now next is, now size of bacteria is 0.0000005 meter. So now if we convert it into the standard form, now how many digits after the decimal is what? 1, 2, 3, 4, 5, 6, 7. So we can write 5.0 into 10 raised to power, what is? Yes, we can write 10 raised to power minus 7. What is? Minus 7 meter. This is the answer of this part. Yes, now the next is size of a plant cell is 0.0000125 meter. Okay, got it? So here we can write it as, so we have to shift this decimal between 1 and 2. Okay, so how many digits between this point and 2 is? 1, 2, 3, 4, 5. So we can write 1.275. Okay, into 10 raised to power what? 10 raised to power, yes, we can write minus 5 meter. This is what? This is the answer of this problem. This is the answer of this problem. Okay, my dear friends, I hope you understand these things. Yes, now the next one here you can see that. Now, thickness of a thick paper is 0.07 mm. What is? 0.07 mm. Okay, so again, we can easily convert it into like this. So we can write, here is. Okay, so how many digits after the decimal is what? This is 2. So we can write 7 into 10 raised to power minus 2. What is 7 into 10 raised to power minus 2? Got it? Understand, my dear friend? Yes. Now in the next question here you can see that, now in a stock there are 5 books, each of thickness 20 mm, and 5 paper sheets, each of thickness 0.016 mm. 0.016 mm. Okay, so what is the total thickness of the stock? Okay, so here you can see that, here we can write thickness of one book, this is equals to 20 mm. What? 20 mm. Okay, so here is thickness of here is 5 books, thickness of this 5 books is equals to 20 into 5. So this is what? 100 mm. What is 100 mm? Okay, and we know that thickness of one paper sheet is, here is thickness of one paper sheet. This is what? This is, it is given that 0.016 mm. 0.016 mm. Okay, so thickness of 5 paper sheet will be, so thickness of 5 paper sheet is equals to 5 into 0.016. Okay, and this will be 0.08 mm. Okay, my dear friend, I hope you get this point. So total thickness of stock is, total thickness of a stock is, this is 100 plus 0.08, 100 plus 0.08. So we can write it as 100.08 mm. 100.08 mm. I hope you understand these things, my dear friend. Now if we write this in the standard form, we can write it as 1.0008 into, here is, we are shifting to the left, so here if we put this decimal at this point, so here we get, we can write 10 raised to power what? 10 raised to power 2. What is 10 raised to power 2? Because we are converting large number, okay, large number to the standard form. Okay, so this is in mm. So I hope, my dear friend, you understand these things. So this is what? This is the answer of this problem. Okay, my dear friends. Yes, now write the following in standard form. Now here we have to write in the standard form. So how we can write it? So this is again very easy. Okay, so here we can write it as 0.0035. Okay, if we remove this point, here we get 10000, because after this decimal we have 4 digits. We have what? We have 4 digits. So we can write it as, we can write 35 upon 10,000. Okay, understand, my dear friend? Yes. Now here if we want to place the point after the 3, okay, so we can write it as 3.5 into 10. Okay, 3.5 into 10. So if we remove this point, if we remove this decimal, we get 10 in the denominator and we can cancel this 10 and this 10. And here we have in the denominator is 10 raised to power 4. So this will become like 3.5 into 10 raised to power. Here is base same and the power is different. So we can write, we can subtract this. So we can write 1 minus 4. So this is equals to 3.5 into 10 raised to power minus 3. So this is the another simplest method to write in the standard form. Okay, got it? Yes. Now here we have to write 365.05. Okay, understand? So we have to place, we have to shift this decimal to the, okay, between 6 and 3. Okay, so here how many digits are there between them? So this is, there are 2 digits. So here we can write 3.6505 into 10 raised to power 2. This is the answer, 10 raised to power 2. Okay, now we have to evaluate root 4, okay, whole raised to power minus 3. We can write 4 raised to power, we can write this root as 1 upon 2. okay, and whole raised to power minus 3. And we know that if a raised to power m and whole raised to power n, we can write a raised to power m into n. We know very well, so we can write 4 raised to power 1 upon 2 into minus 3. So this will become 4 raised to power minus 3 upon 2, minus 3 upon 2. And here we have the power is in negative, and we know that if a number which is having the power in negative, we can write it as 1 upon a raised to power m. So this will become like 4, okay. Here we have 4 raised to power minus 3 upon 2. So we can write it as 1 upon 4 raised to power 3 upon 2. We get, this is the answer. We get the answer. 1 upon 4 raised to power 3 upon 2. Okay. Understand, my dear friends? Yes, now the next problem here you can see that here. Now calculate the missing value of x. We have to find the value of this x, okay, in this expression. So here we have 11 upon 9 raised to power 3 into 9 upon 11 raised to power 6. That is 6. And this is equals to 11 upon 9 raised to power 2x minus 1. Now if you observe this, here in the RHS part, here is in this part, we have 11 upon 9 is a base. So we have to make the same base, okay, in the LHS part also. So for this, here we have 11 upon 9, which is 3 raised to power 3 into. If we write 11 upon 9, if we do the reciprocate, then the power will become negative. And this is equals to 11 upon 9, 2x minus 1. This is the power. So here you can see that here is base is same and power is different, and here is operation is what? Multiplication. So the power will be add. So 11 upon 9 raised to power 3 plus of minus 6, and this is equals to 11 upon 9 2x minus 1. 2x minus 1. So this will become like, now we have to compare the powers. Now compare, because base is what? Same. So compare power of same base. Same base. So here we get, here is, this is 3 plus, this is 3 plus minus minus 6, and this is equals to 2x minus 1. Okay. Now if we solve this, we get minus 3 is equals to 2x minus 1, and this will become 2x is equals to minus 3 plus 1. This is minus 2. And x is what? Minus 2 upon 2. This will be cancelled one time. So here we get x is equals to minus 1. We get what? X is equals to minus 1. This is the answer of this problem. Okay, understand? Yes. Now the next problem here you can see that if a newborn bear weighs 4 kg, okay, now calculate how many kilograms a 5-year-old bear weight if its weight increases by the power of 2 in 5 years. Power of 2 in 5 years. Now here you can observe this. Weight of newborn bear is 4 kg. Okay. So rate of weight increase in 5 years. In 5 years. This is what? This is power to 2. This is power to 2. And thus we can write thus the weight of the weight of the 5-year, got it, 5-year old bear is what? 4 raised to power 2, which is what? Which is 16 kg. Which is 16 kg. This is the answer. Okay. Yes. Now the next question here you can see that by what number should 5 raised to power minus 1 be multiplied so that the product may be equal to minus 7 raised to power minus 1. Okay. Now here is, let us consider a number x. Let us consider a number x. So here is 5 raised to power minus 1 into x. Here it is saying that what number should 5 raised to power minus 1 be multiplied. So here we are multiplied with that. So the result will be minus 7 raised to power minus 1. Minus 7 raised to power minus 1. Okay. Here we can write 5 raised to power minus 1 as 1 upon 5 into x is equals to, we can write it as minus, here is 1 upon minus 7. This will be, the power will become positive. Now here you can see that x will be, okay, now you can see that here is this 5 is what, this 5 is in division, and if we shift to this RHS, this will go in the numerator, okay, in the multiplication. So this will become 5 upon minus 7. So the result is what, x is minus 5 upon 7. What is minus 5 upon 7? So this is very easy. Okay, I hope you understand these things, my dear friend. This is the answer of this problem. Okay, yes, so now my dear friend, this is enough for today, and we will meet in the next lecture with the next amazing topic. So thank you very much for listening me, and take care and goodbye.